Hi students, and welcome to another HSC Chemistry video in the acidic environment series. This one's going to be about calculating gas volume. So most of this is going to be pretty much just a revision of some of the things that we've looked at previously, but we need to apply them in a slightly different way. To, I guess, just review some of the important gas laws that we looked at in the preliminary course, and to, I guess, transfer them into the relevant sections of our HSC course. The most important thing is that the same temperature and pressure equal volumes of gas contain the same number of molecules. That is the same number of moles. The consequence of that is that at standard temperature and pressure, that is 0 degrees Celsius or 273 Kelvin and 100 kilopascals, 1 mole of any gas will occupy 22.71 litres. Likewise, at room temperature and pressure, or normal temperature and pressure, or sometimes standard laboratory conditions, which is 25 degrees or 298 Kelvin and 100 kilopascals, 1 mole of any gas will occupy 24.79 litres. Now, this is 1 mole of the gas, and so what we need to do when we're doing our calculations involving gases is to identify how many moles we have, and then we can very quickly convert that into a value in litres. Now, these values here are on your data sheet, which you will be provided with for any of your exams, including your HSC. So you don't have to memorize these values, although you'll probably use them enough. Hopefully, you'll use them enough before you get that far to have them memorized. But they are always on the sheet, and you will be able to just use them without actually having to try to put them into your memory. So what does this mean in practice? Well, let's say we have 50 grams of sulfur reacting with excess oxygen from the air to produce sulfur dioxide gas. Well, the first thing we obviously need to do is we need to write an equation. So sulfur with excess oxygen just means everything's going to react, and then we're going to produce sulfur dioxide gas. Okay, so we write our equation, sulfur plus oxygen gives sulfur dioxide gas. Then we make sure that we need to balance the equation. So I have 1 sulfur and 1 sulfur here. I have 2 oxygens here and 2 oxygens here, so it's balanced. So very importantly, my mole ratio, which is the coefficients out the front of each of these, is 1 to 1 to 1. Now I need to calculate the mass of oxygen needed for complete combustion. So the mass of oxygen needed for complete combustion. So what I know I have is 50 grams of sulfur. So therefore, the number of moles is equal to the mass over the molar mass. And so this is going to be 50 grams over 32.07. And so I'm just going to have to just grab myself a little calculator to do that particular sum. And when I divide 50 by 32.07, then I get 1.55. Actually, let me just double check that again. Just knocked it off too quickly. 1.56. I thought I had to round it. Okay, so I'm just going to move that away from there. 1.56 moles. Now, the mole ratio we said before was 1 to 1, so therefore, this is here 1 to 1, so therefore 1.6 moles of sulfur requires 1.56 moles of oxygen. Now it's O2. Now we know that each individual atom of oxygen is 16, so 16 plus 16 is 32. So therefore, the mass is equal to 1.56 times 32, which is the same as, pretty close to what we had before because it wasn't very different. So 49.9 grams, 49.9 grams of oxygen are needed for complete combustion. And what volume of sulfur would be produced at STP? So standard temperature and pressure is 22. 1 mole is to 22.71 litres. So the volume of sulfur dioxide, so I need to know the number of moles, and sulfur dioxide is here, and I said my ratio is 1 to 1 to 1. So therefore, if I have 1.56 moles of sulfur, I will produce 1.56 moles of sulfur dioxide. And so therefore, the number of liters, the volume, is going to be equal to 1.56 times 22.71. And I will just do that one on the calculator. 22.71, and that gives me a value of 35.4, equal to 35.4 litres. Now, one other quick point that I'll leave you with is we need to, when we're doing our questions in chemistry, we need to look at our number of significant figures. So when I go back to my original question, the only information I have is 50. Now, this is actually one significant figure. So therefore, when I'm going through my calculations, effectively, it makes little sense for me to do too much of the simplifying or rounding up too early. So that would mean that this figure would come back to 50 grams, which is rounded up to one significant figure. And of course, this one actually would go to 40 litres, which seems rather silly roundup. So I would accept it in this case if you just left it at those two figures, 35 litres in this case, and I'll give you a mark for that. Generally speaking, we'll have a few more than just the one significant figure. I wouldn't expect you to write this down as 5 times 10 to the 1 grams. We'd probably write this down as 5.0 times 10 to the 1, and therefore that gives us a second sig fig, which still brings this to 50 and this to 35. Thanks for watching.